You know, Craig, it seems that in organic chemistry labs there is often a step involved called heating under reflux.
Heating is important because it causes a reaction to occur faster and thus finish quicker. A solvent is used usually not to react, but to dissolve the reagent at its boiling point. Let's watch the stagehands set up a reflux.
To conduct a reaction at the boiling point of the solvent, we use a water-cooled condenser to return the solvent vapors to the reaction vessel and prevent their escape. The condenser has cold water circulating around the outside of the inner glass, so that the hot, rising vapor cools, condenses back to a liquid, and drips back into the reaction vessel. This process of boiling a reaction mixture and condensing the solvent vapors back into the reaction vessel is known as heating under reflux, or simply refluxing. Now let's look at how to set up the apparatus. First, select a heat source. A steam bath is used for flammable solvents boiling between room temperature and 85 degrees Celsius, while a heating mantle with its variable electronic control is used for flammable solvents which boil between room temperature and 200 degrees Celsius. Sometimes you may choose a Bunsen burner for non-flammable solvents such as water, which boil between 100 and 200 degrees Celsius. The key to setting up any piece of apparatus is to start from the bottom. Usually you start by setting a lab jack in place. Lab jacks are used because they provide a quick and easy way to remove your heat source. They are not usually used with a Bunsen burner, but are convenient to use with a steam bath. Place the bath on the jack and make sure that it is stable. Then test to see if the jack moves up and down freely and that your hose are of appropriate length. Select the flask size so that it will be no more than half full when all reagents are present. Clamp the round-bottom flask in place with the bottom of the flask about 5 to 10 centimeters above the heat source, then put the condenser in place. Connect the bottom water inlet on the condenser jacket with a length of rubber tubing to the cold water tap. Incoming water is always attached to and clamped at the lower point. Run another length of tubing from the water outlet, the upper connector, to a sink, making sure that it is long enough to prevent splashing when the water is turned on. Secure the hoses to the condenser and to the tap with small clips to prevent water leakage. Failure to properly secure your hoses can lead to pop-offs, which may decrease your popularity with your lab mates. Turn on the water carefully so that the condenser jacket fills slowly with water from the bottom up. Air bubbles are common but will bleed out. Adjust the flow rate so that it is just great enough to maintain a continuous flow of water to keep the condenser at the temperature of the tap water during the reaction. You now have completed the assembly of your apparatus and you are ready to add reagents. First, remove your condenser carefully and place it on the bench. Add some boiling stones to the round-bottom flask. If you must add a solid reagent, it is transferred to the flask using a powder funnel or folded piece of paper. Liquid reagents are added through a long-stemmed funnel. The reactants are mixed by swirling and the condenser replaced. Normally, it is a good idea to grease the top part of the condenser joint, of course after the addition of solid reagents is complete. This stops the joints from freezing, that is, sticking together. It is important to add boiling stones before heating begins, since the liquid may froth violently and boil over if they are added when the liquid is hot. Although it may be spectacular as the solvent shoots out the top of the condenser, it is dangerous and also annoying to have to set up your reaction again. Always add 1 or 2 new boiling stones to a cooling liquid before reheating. This is because liquid is drawn into the pores of a boiling stone when boiling stops making the stone less efficient. You are now ready to start heating. Raise the lab jack up to the bottom of the flask and slowly apply heat. Open the steam in this case, and note when the solvent starts to reflux. Directly in line with the bottom of the hose, we see vapors passing into the condenser, forming a reflux ring of condensate. Below, solvent will be seen flowing back into the flask. Above, the condenser will be dry. The vapors should rise between the water in and water out portion of the condenser. If they rise to the top of the condenser or are seen being emitted into the room, too much heat is being supplied to the flask or the flow of water through the condenser is insufficient. When reflux is complete, turn off the heat source and remove it from contact with the flask. Cool the apparatus to room temperature, then turn off the condenser water. Clean the reaction flask as soon as possible so that residues do not dry on the glass. Let's review the steps.